Atoms of elements are rarely found by themselves in nature. Everything around us is made up of elements, molecules, or compounds. The millions of different chemical compounds that make up everything on Barth are composed of 118 elements that join together in different ways. The 118 known elements interact with one another to create new, unique compounds that have entirely different chemical and physical properties from the elements that make them up. This is because the forces of attraction between the same or different atoms of these elements form molecules or compounds. The attractive forces that hold atoms together in compounds are also known as chemical bonds. All the inorganic and organic materials we use are created with the help of chemical bonding. Every day, the water we drink, the oxygen we breathe, the salt and sugar we use, the proteins we need, the carbohydrates we eat, the fuels, the gas and plastics we use, and the medicines we need to cure ourselves are all the results of chemical bonding between atoms. Chemical bonds also play an important role in all living things because they hold together the cells in our bodies. Basic concepts of bond formation, such as ionic bonds and covalent bonds between atoms and their physical properties, have been introduced in grade 10 chemistry. This chapter further explores different types of bonding, emphasizing their strengths and structures. In addition, how to depict molecular structures of molecules and how to predict the shapes of molecules are also included. 11 basic concepts to understand chemical bonding. Since the discovery of the electronic structure of atoms, referred to the grade 10 chemistry textbook, scientists have been able to investigate the ways in which atoms of the same or different elements can combine with one another. The outermost shell electrons, valence electrons, of those atoms are the basis for understanding the joining of atoms. This interaction of electrons leads to the forces of attraction, chemical bonds, that hold atoms together in substances. Electronic structure and energy levels of electrons. In order to explain the electronic structures of atoms, the principles of filling electrons in the atomic orbitals, such as the Aufbau principle, Pauli's exclusion principle, and Hund's rule, are fundamental to understand. In atoms, there are K, L, M, N main shells, and each main shell can be divided into S, P, D, and F subshells. Each subshell can be filled with 2, 6, 10, and 14 electrons, respectively. Each of these subshells contains spaces for electrons called orbitals. In addition, S subshell has only one spherical-shaped orbital. There are 3 dumbbell-shaped p orbitals, p pi p, and the 5 d orbitals have double dumbbell shapes. According to the Aufbau principle, Aufbau means building up in German, electrons are filled in the lower energy atomic orbitals before filling higher energy ones. The order of filling the orbitals is given as 1 s2, s2p, 3 s3p, 4 s3d, 4p. Moreover, to understand how many electrons can fit into an orbital, one of the properties of the electron, known as spin, has to be considered. Each electron spins on an axis like a globe. It can only spin in 2 directions, represented with arrows as t or 1. In order to occupy the same orbital, electrons must have opposite spins, 11. That is, 2 electrons with the same spin cannot occupy the same orbital. Pauli's exclusion principle states that no more than 2 electrons can occupy the same orbital, and 2 electrons in the same orbital must have opposite spins. Furthermore, Hund's rule states that every orbital in a subshell is singly occupied with 1 electron before any one orbital is doubly occupied with opposite spins, and all electrons in singly occupied orbitals have the same spin. On the basis of these principles and rule, the description of electronic configurations of some elements is illustrated in Figure 1.1. Atoms of elements